Average rates of change. When we find an average rate of change for a function, we basically are finding the slope of a line that goes through 2 points on that function. Now, if we have a linear function, of course that slope is going to be the same everywhere. But in any nonlinear function, the points you use, each pair of points that you use, will yield a different average rate of change. So in this diagram, the blue function is the function f of x. In order to calculate the average rate of change between this point and this point, what I would have to do is find the slope of the line that goes through those 2 points. We call this the secant line. So if you know how to find a slope, you know how to find an average rate of change. Our slope formula, remember, involves subtracting the y coordinates on top and subtracting the x coordinates on the bottom. Remember, the little subscripts here simply refer you to which point those are coming from. So let's look at this function. I know that f of 1 is equal to 12, so that gives me the ordered pair 1, 12. And I also know that f of 4 equals negative 3. So that gives me another ordered pair 4, negative 3. In order to find the average rate of change from 1 to 4, this refers to my x value of 1 and my x value of 4. I simply find my slope using these points. So that's the second y minus the first y over the second x minus the first x. So my second y is negative 3 minus my first y is 12. And that goes over the second x, which is 4, minus the first x, which is 1. So this gives me negative 15 over 3. That simplifies to negative 5. So that slope, or average rate of change, from 1 to 4 is negative 5. So every time the y goes down by 5 units, the x would go up by 1, because remember, this is like having negative 5 over 1. Now here's an application where we're finding an average rate of change. On dry level pavement, the stopping distance for a car traveling at x miles per hour is 1 over 11 x squared. Okay, now that distance is in feet. So let me put that in here, feet. Find the average rate of change from 11 to 22 miles per hour. So my x values I'm going to use are 11 and 22. So in order to use those, I need to know my y values that go with them. So I have to plug into my function to get the y values. F of 11 would be 1 over 11 times 11 squared, which is 1 over 11 times 121. So that I know will be 11. And then f of 22 is 1 over 11 times 22 squared. Now, if you don't know what 22 squared is, you could go to your calculator, do 22. Let me make it a little bigger so you can see it here. 22 squared is 484. So then I just need to divide that by 11, or multiply it by 1 over 11. And that gives me a y value of 44. Now, I know my 2 points. Now I need to find my slope. So I want the second y minus the first y over the second x minus the first x. So that's going to give me 44 minus 11 on top. And it's going to give me 22 minus 11 on bottom. So I get 33 over 11, which is 3. So what this means is every time your speed increases 1 mile an hour, because remember this is understood to be over 1, every time your speed increases 1 mile per hour, your stopping distance increases by 3 feet. So our slope here, our average rate of change, is 3 feet per every mile per hour, or just 3. You can just say 3.